Okay, I see Mohammed is also here. Okay, I think we are ready to start, and we are also recording the webinar so everyone can have it after, everyone who are not joining right in time. Okay, so let me go here. Perfect. So hello and welcome everyone, students, researchers and professors from the academic community in India, and those that are not based in India but were still interested in joining in today's webinar. My name is Mateo Galia. I'm the academic program coordinator here at GAMS, and today I'm very excited for this special webinar about GAMSPy and the power of optimizing in Python. For those of you maybe new to GAMS, as a company, we have a very long and also proud history of both supporting and collaborating with academia all over the world. And today we are here recognizing the very impressive talent and innovation that's currently coming from academic institutions across India. And the idea for this webinar, just to give a little bit of context, came a couple of months ago where one of our colleagues attended the Think India conference at IIT Roorkee. And she was very impressed and also very excited because there was a huge interest in GAMS and especially in GAMSPy. So she talked with a lot of students and researchers. Perhaps many of you are here today. And there was a lot of interest, but also a lot of questions. So we decided to host this webinar to hopefully answer those questions and to also give you a hands-on experience of what is GAMSPy, what you can do with it, and how you as part of the academic community can best take advantage of it. So before we move on, I will give a quick overview of the agenda for today's webinar. So if we can start the presentation, we'll go over it quickly. Vijay, should we start the slides? There we go. Perfect. Should we go to the next one, which is the agenda for today? Yes, perfect. So first of all, we will give a very brief introduction and talk in general about optimization. Then we will briefly talk about what is GAMS for those of you who might not be familiar with us. Then we will introduce GAMSPy and optimizing in Python. And then we will go to the heart of this webinar, which is our live demo. It will be a tutorial on how to write and solve an optimization problem using GAMSPy. And in this case, it will be a transportation problem. Then we will make the argument of why GAMSPy and why we think you should definitely give it a try. Then we'll have a brief summary. And then for the final part of this webinar, we will spend a couple of minutes talking about our academic program and other interesting resources that you can take advantage of. And finally, we will have time for a Q&A session. So let me just say that if you have any questions along the webinar, you can just put them on the chat. These questions will be visible only to us hosts. And then during the Q&A session, we will try to answer all of them. If we don't have time to answer all the questions, we will follow up with you after via email. Okay, so that's it for the agenda. And now for the technical and interesting part of the webinar, let me introduce and hand it over to Vaibhav. He's an operations research analyst here at GAMS. He holds a bachelor's and a master's degree from Delhi University, and then a second master's from the Otto von Guericke University in Magdeburg, Germany. And also joining us today and ready to help with any technical question is Mohamed Soytürk, who is a software engineer here at GAMS, and he's also the main developer of GAMSPy. So we really have a stellar team here today. So let me just welcome again, everyone, and let me hand it over to you, Vaibhav.
Thank you. Thanks a lot, Mateo, for the warm introduction. And hi, everyone. My name is Vaibhav, and it's great to see all you joining the webinar. I'll try to keep this as interesting as possible and hope that you find something useful from this session. But yeah, before we dive into the technical stuff, let's take a step back and talk about what solving complex real-world problems actually look like. As we all know, applied mathematical optimization is all about tackling these kind of challenges. And sure, it would be great if it is just about building the perfect model. But in reality, there's a lot more to it. We need to handle data carefully, visualize it well, and deal with the messy details that comes with the real world scenarios, which often leads to this optimization pipeline. That is, after hours of implementing and developing, we end up with this huge optimization pipeline that includes reading data, pre-processing data with various tools, for example, Excel, and the mathematical model in a language such as GAMS, and again, post-processing and visualization in other languages or environment like Python or R. So let's be honest, data manipulation, pre and post processing can be a time consuming and a tedious task, especially when working with a domain specific modeling knowledge or language, GAMS. And this brings us to Python. As we all know, Python has become this one stop solution, be it pre or post processing or visualization. We can do all that in Python. It offers a vast array of packages to handle all these tasks and is often a shared language in an organization spanning group. This could introduce a bottleneck when we want to communicate between Python and a language like GAMS for our optimization needs. And this is where GAMSPy comes into the picture. It provides a comfortable and efficient way of modeling the optimization problem in Python. In simple terms, we can now have everything within one environment, and that is Python. But before we introduce GAMSPy, let's first talk about what GAMS is. So GAMS basically stands for General Algebraic Modeling System. It has been in active development since 1987. What GAMS allows us to do is define mathematical models like we are writing on paper. For example, as you can see, we have a transportation problem defined within GAMS, similar to how we would write the algebraic model for the problem on paper. So we have the parameters and the variables defined over sets, and the constraints are written in a way that closely resembles the algebraic notation. But what about the data? Well, GAMS allows to write completely abstract model. That means it is data agnostic. And when we want to solve the model, we just all we need to do is import the data from the chosen format and then execute the solve statement, which also generates the model during the solve statement. And this is the GAMS philosophy, that tight syntax leads to better modeling. In a nutshell, GAMS is a stable, efficient algebraic modeling language which is being actively developed since 1987. The data itself is held in GAMS structure, which makes it so fast and ready for very large models. With this in mind, we can now introduce GAMSPy. Well, GAMSPy again is also a algebraic modeling language, but now we can write our models in Python. It brings the same goodies from GAMS as it is using GAMS in the background. So it is really fast and efficient while generating the model. It uses and convenient, efficient data structures from libraries like NumPy and Pandas. And now we can have our entire pipeline from start to the finish in Python with the help of GAMSPy. In order to demonstrate this, let's consider the transportation problem as an example. So I'll give a brief introduction about the transportation problem as to understand what we're dealing with. The problem contains some suppliers, in our case, the canning plants at San Diego and Seattle, and some markets, namely at New York, Chicago, and Topeka. The problem is to satisfy the demand at these markets while respecting the capacity at the plants and finding the optimal number of shipments that minimizes the total transportation cost. We can also view this in a network diagram. So on the left-hand side, we have our supply or the production sites. And on the right, we have our markets. And you can see in between, we have the listed capacities and the demands respectively. Connecting them, we have the distances in between. And of course, the objective is to minimize the transportation cost, subject to the demand satisfaction at the market, and respecting the capacities at these uh, supply points. Next, we can formulate this problem as a mathematical model. And here we have like two indices which are controlling the canning plants and our markets. So basically our set I is the canning plants and set J is representing the markets. Then we have our decision variable, or xij, the number that represents the number of cases to ship from plant I to market J. For the data, we have the CIJ, that is the transportation cost per case to ship from plant I to market J. Then AI, which is the production capacity of plant I, and the BJ, which is the demand of market J. Our objective is again to minimize the total transportation costs, which is just the sum over all I and J of Cij times Xij. Finally, we have the constraints, namely that we cannot ship more from plant I than the total production capacity of that plant. We must ship enough market to satisfy the demand at uh, uh, to satisfy the demand at the market J. And we know that a number of cases to be shipped from I to J must be positive. That is, we do not want to ship from the market back to the plant. And now for the exciting part, uh, let's see. I've prepared a Jupyter notebook, and I can bring the screen over here. And by the way, you can find this Jupyter notebook and a couple of more examples in the official documentation. We can also provide the relevant links at the end of the presentation. So first and foremost, we have some explanation of what the transportation problem is like. And then, as we said, all we have to do to use GAMSPy, in order to use GAMSPy, is first install. And it's just as calling the pip install GAMSPy. Once we are done, we are ready to, as with any Python project, we can import all the necessary components we require to formulate our model in Python. For this one, we'll be requiring all of these. So let's go ahead and run this. Next comes is our declaration of the container. So container is basically the, so to say, the centralized hub in GAMSPy environment, which will be containing as the which will be containing all the necessary sets and parameters and all the variables which we saw in the mathematical model for us in the GAMSPy environment. Now that we have defined a container called M, next we can go ahead and define our sets. And again, as we had in the mathematical model, in GAMSPy again, the sets are the fundamental building blocks. Basically, everything from parameters to variables to the equation will be control over your sets. And in this case, we have two sets, namely I and J. And for brevity, we can just name it the same as the mathematical notation. So I and J. We can also give it a description, but that is just for the sake of explanation and doesn't really help in the optimization process. The usual way of declaring any set or a parameter is defining where that symbol would live. So in our case, it's in the container M. Next, we give it a name. And this is nice. Like if we want to not give it a name, GAMSPy is smart enough to generate a name for the symbol itself, but this is not recommended. So for example, if you want to use a symbol later on in your code, you can just reference it from the container. But if you don't have a name, it might be difficult. So our suggestion is to, you know, uh, give a name to all your symbols which you define. Once we have the sets declared, we can go ahead and define our parameters. Just like we have in the examples, we can have, sorry, just like we had in the mathematical model, we have our three parameters. So namely A, where that will contain the supply of commodity at plant I. And then we have the parameter B, which is again living in the container M. And we have given it the name B. The domain in this case is J. So basically we are wanting to capture the demand for every market, and that's why the domain is J. Finally, we have the cost per unit of shipment between the plant I and market J, and we represent that using the Python variable C, and just storing it in the container M with the name C over the domain I and J. Once we have defined the parameters, the next step is to define our variable. In our case, it's only one variable. It is living in the same container M. We can give it a name, let's say X. The domain will be I and J because we want to capture the amount of commodity to be shipped from the plant I to market J. And the type will be positive in this case because we don't want the negative. We don't want the amount of commodity to be negative. That is, we don't want the commodity to be shipped from the market back to the plant. Once we have the variable defined, we can get to the equations, or so to say, the constraints. The way we define constraints in GAMSPy is, yeah, the calling this equation operator, and it's the similar method. We first have to know where the equation would reside. So in this case, in the container M, we get give it a name, supply. In this case, the domain will be I. So for each plant, we have to respect the supply constraint. Similarly, for the demand, we mention the container, the name, and the domain. And we know, okay, that for every market, we have a demand. So the domain will be J, followed by some description. We can go ahead and run that. Finally, for the definition itself, it is as easy as writing your algebraic model. So for example, in this case, we have a supply. For the supply constraint, we have for each plant I, we want the sum of all the commodities to be shipped from the plant I to J to be less than or equal to, for that matter, uh, the supply at or the capacity at plant I. We can go ahead and run this one. Oops. Yeah. Similarly, for the demand, we have it for each market. We want to satisfy that the demand is met, which is, summing over for each supplier. The sum of the commodity to be shipped should be greater than or equal to the demand at the market J. We can also get a LaTeX representation of each of these equations. So for example, we want to represent the LaTeX. Oops. And now we have some error. Uh, yeah, so but the idea is we can represent the LaTeX, we can have the LaTeX representation of each equation using this convenient wrapper function called LaTeX wrapper. And in essence, we have this representation of the equation. Finally, we can define our objective. Defining an objective is similar as writing a constraint, but we don't have to declare an equation for that matter. We just have to assign the equation or the constraint to a Python object, in this case, obj. And then we just say, okay, we want to sum over all I and j, where we want to have the product of the cost and the amount of commodities shipped. Now that we have the objective, we are finally ready to consolidate all these different symbols, all your sets, parameters, equations, and your variable into a model. The way we do it is just call the operator model and we say where it is living. So again, in the container M, we give it a name, say transport. Uh, and then there are two ways of defining what equations goes into a model. So one way is to either say we want the supply equation, which we defined earlier, or the demand equations as the equation. Or what we can do is we can go ahead and use this convenient method called get equations. And this will fetch all the equations which we have from the container. And yeah, just initialize the model class. We can then define a problem type. In this case, it's going to be a linear programming problem. The sense will be to minimize. We want to minimize the objective. And finally, we can provide the objective itself. So let's go ahead and run this one. Perfect. And then as you can see, till this point, there was no need to introduce any data. So it was really data agnostic. We already have a mathematical model for the transportation problem, and we don't require the data at all. And now that we want to solve the problem itself, let's start, inserting some data inside. And again, there are a couple of ways of doing this. So here we can use your normal Python lists or your tuples or list of tuples to insert your records inside these symbols. So for again, because we had I as our set of canning plants, so we insert the Seattle and San Diego in this one, and J was our market, so we insert all the markets, and then A and B were our um, supplies and the demand at these two cities. Finally, we can also see the records by just saying I dot records, and we'll have a nice data frame which we can view and verify that okay, we have already inserted Seattle and San Diego inside our symbol I. We can also, let's say we have the distance as a pandas data frame. What we can do is during the definition of the like during when we are defining the parameter d or the distance, we can do all the same things which we did earlier, but use this records parameter and then just pass on the pandas data frame. And this will essentially create a GAMSPy object D. And we can view that object by just saying d.records. And we can verify this. And yeah, we have the necessary data in our GAMSPy object. And for the final piece of puzzle, we require the cost, so Cij. This is basically the freight cost times the distance divided by 1,000. And this is how we want to represent the cost in this scenario. All we have to do is, again, choose a couple of from the couple of options, how we want to uh, define the cost or initialize the cost. So we can do it in the Python way. Um, we can define everything using the Python data frames and set this record C, or we can use the GAMSPy assignment. We already have freight cost as a integer, let's say 90. The Dij was our parameter, and we divide that parameter by 1,000, and we can get back our parameter C or the costs in a nice GAMSPy symbol. And we can view this by, again, C dot records. Finally, we are ready to solve the model. And at this stage, we just have to, run this. Oops. And now I can't even run this. I see. Yeah, let's go ahead and run everything. And this is the nice part.
You probably didn't
Yeah, define
the
that one. Yeah, yeah. Yeah, this is the nice part of live demo. We get to debug everything. I guess now we are ready to solve the model. So yeah, if you want to get the output in the console, we can just provide this this parameter output and set this to the standard out by specifying this sys.stdout, and then we can have the nice solver log within our console. And we can finally see that, okay, the status was normal, the model status was optimal global. That means we found a global solution. And the objective value is 153.675. That is the minimum transportation cost. We also have some other metrics that is useful in case of debugging. But what about like verifying the generated model? So we can see, okay, we have generated a total of 6 equation, and we also have a total of 7 variables. We can do so by simply passing a couple of options in the same solve statements. So let's say we want to generate 10 equations and 10 variables. So we specify these two options and set the limit to 10. And we call the solve model once again. And now we are ready to, if we want to verify, we are ready to call these um, convenient methods. So if we want to see all the equations in the model, we can call it on the model object itself. So let's say transport.get equation listing. We'll have all the equations in the model. And we can also get all the variables in the model. So just say transport.get variable listing, and we'll have all the variables in the model with their lower bound, the level, upper bound, and the marginal information. We also get the objective variable listed. And we can also get this for each uh, constraint that we define. So for example, if you want to list just for the supply constraint, we can do this and run, and it'll only print for the supply. And then again, yeah, this is also true for the variable itself. And if you want to do that, you just say x dot get variable listing. Now we have just the variable minus the objective variable. And yeah, retrieving the results itself is as easy as just saying x dot records. We have seen this earlier. We can just go ahead and do an x dot records, and we get all the information. And you have all these nice information about the level, marginal, lower, and upper scale, and you can view everything by this. So for example, if I want to get only the marginal, we can say x dot m, and I get the same parameter back in this. And if I want to get the pandas data frame record, I run this, I just get the marginals of my variable. Finally, we can also get the objective value, which is in this case is 153.675. Okay, so for the students amongst us, we can also convert our GAMSPy model to LaTeX. It is as easy as calling the toLaTeX method on the model object. We just have to specify the path and it'll generate the text model in our case. So for example, this one, we have a nice text representation of our GAMSPy model. And if, let's say, if you have the utility PDF LaTeX, we can also say generate PDF to, we can also set this parameter true, and then it'll use this text file to generate your PDF file for your model. Or, I mean, to be honest, I can just use this tech file and paste it into Overleaf if you use that. And that's even convenient.
This is especially convenient for
Yeah.
mathematicians because sometimes they model their model and I mean, since they are not very good at programming, it's harder to debug. So they generate the LaTeX file and
Yes,
see the actual mathematical representation.
absolutely. And similarly, we can convert the GAMSPy model back to GAMS. And this is again as simple as calling the toGAMS method and giving it a path. And if we go ahead and run this, we see we have generated the transport.gms file, and we can view, and we also have the .gdx, which is the way of storing the data in GAMS. If we go back to the Jupyter notebook, and here I've also, extended the usual example by getting the matplotlib into picture to complete the loop, so to say, or to complete the circle, that we can have, the data input and data cleaning, everything from Python in Python, and then the post-processing part where we get to visualize the solution in Python itself. So let's for this, you just require some latitude and longitude for your cities or your suppliers and markets. And with some Python magic, we can generate a quick and dirty, I would say, plot which will visualize our solution. So as you can see, we have our Seattle and San Diego as the suppliers on the left-hand side, and we are able to generate this optimal supply flow from these suppliers to the markets on the right with their, supplies between them. And that's it from the live demo. Now I guess we can switch back to the presentation for this. And yeah, then we can answer why GAMSPy. Well, as you can see, it's as easy as running pip install GAMSPy. We have already released a stable version. We have a up-to-date documentation. It's always getting updated, and we do have a model library with 100 plus models, uh, which you can reference and play around with. Then we also have solver independence. So, for example, we were using Cplex um, in our in our uh, in our example. We were using Cplex, and if you wanted to use, let's say, um, IPOP-TH for that matter, we can go ahead and do this by just saying transport.solve and set the solver as IPOP-TH and run this. Oh, I think I need to do the output sys dot std out. And if we run this, we see again that, okay, now GAMSPy is using IPOP-TH in the background to solve a model. So this really makes GAMSPy solver independent.
Yeah,
And
actually, in the QA, someone asked about using Groby.
oh, yes.
Yeah, you can do it in the same way. You can just
Yes,
install
absolutely.
Groby solver with GAMSPy install solver Groby and set the solver to Groby, and that's it.
Exactly. Yeah. It's as simple as, just installing the solver. So for example, I can show you quickly. We have a nice CLI for this. And let's say we want to list all the solvers. For now, we can see, okay, we have all the solvers for different type of problems. And if we want to install highs, or let's say Groby, I'm not going to install it right now. So, but let's say I want to install highs. I can go ahead and say group GAMSPy install solver highs. And it'll go ahead and I think it is installing.
Yeah, I mean, for some reason in the last hour, there is a huge problem with the PyPy server. So
Oh,
for
really?
GAMSPy highs, 49.
I mean, yeah, the idea is basically, if you want to list all the solvers which GAMSPy supports, we can do that using list solver and just say all dash A. And then we have all the solvers which we can use with GAMSPy. So we can see, okay, we can use Groby, highs, IPOP-T, IPOP-TH, and everything. And yeah, choosing the solver depends on what kind of problem you are trying to solve. But yeah, it is as easy as running the command GAMSPy and install solver highs. Oops. Yeah. But yeah, I guess right now there is a problem with the PyPy in the background.
Yeah, for some reason it's very
Yeah.
unreliable.
Yeah. Okay. So let's keep moving ahead. Yeah, we saw the solver independence, and of course, we saw the data independence. For example, in some other libraries, we have to start by getting the data and cleaning process, and then we are, ready to define our problem or the model. But in GAMSPy, we can do all that without the data. We can define the model with all the sets and parameters and variables and equation. Just as when we are ready to solve the model, we can just import the model from wherever we want to in the correct format, of course. And then we can just, call the solver and solve our model. And why GAMSPy? Of course, it's very convenient. So for example, because it is devoid of any data. So let's say in this example, we defined a variable over this domain I and j because we wanted to capture the commodity flow from the plant I to the market j. But I made a mistake. And in the demand constraint, instead of specifying xij, I specified xjj. Well, that of course is a problem. And the way GAMSPy handles is just generating a error really early on as compared to some other modeling languages, which they have to look at the data and then verify, okay, well, J is not really a supplier, so that should not be there. But that's not the case in GAMSPy. It really catches the bug early on and gives a really helpful message. And we can debug pretty quickly and say, okay, we made a mistake and we have to use Xij instead of XJJ. And this is GAMS philosophy in a nutshell. That is, tight syntax leads to better modeling. And finally, the performance. And we know the GAMSPy is really fast in generating the models and, of course, solving the models. And the same thing goes to GAMSPy as well, because GAMSPy is using GAMS in the background to generate the models and solving. So it gets all the benefit what GAMS has as well. You can also read a little bit more about this in our nice blog post with more technical details and a more in-depth analysis of this performance. And of course, as we saw about the interoperability, that how we can convert the GAMSPy code to LaTeX or GAMS for that matter. We can also, let's say you want a web application for your GAMS model, we can just pass it to the Miro application. And it's as easy as changing one parameter in our GAMSPy model. And if you want to deploy the GAMS model, let's say in some AWS architecture or infrastructure, we can do so using the GAMS engine. And we have all this different uh, software in our suite, which allows us to uh, even present and deploy the solution from scratch to the end line. Quickly summarizing everything, GAMSPy generates mathematical model and not instances, as we saw. It is devoid of any specific data. It is truly data agnostic. GAMSPy leverages GAMS backend, so it executes the assignment operations and generates and solves the models. GAMSPy can access a broad set of state-of-the-art optimization solvers, as we saw. It's the changing from Cplex to IPOPTH or to GuruB for that matter is as easy as specifying the parameter. And to be honest, it's the unique way and the streamlined way of completing all these tasks like pre and post processing and the visualization. Everything is now in one single environment. And again, GAMSPy can work seamlessly with GAMS Miro, GAMS Engine, and Neos. Like if you want to solve your model instead of local machine on cloud or an AWS architecture or AWS machine, you can do so with Neos. And finally, to reiterate the point, GAMSPy is as easy to use or easy to install with just one line of code. Just say pip install GAMSPy and you can get ahead. You can start using. All right. I mean, that's all from my side. That's all I wanted to present for this session. I hope it was insightful and I was able to convince some of you to start using GAMSPy. Now I would like to give it back to my colleague, Matteo, who would be speaking about the academic program. Over to you,
Yes,
Matteo. Thank you.
thanks, Vijay. And hello again, everyone. I also hope you found the tutorial insightful, that are starting to see the potential of integrating GAMS with Python in GAMSPy and how to use it for your work. Now I'd like to take just a few minutes to tell you about our academic program and how we try to support the academic community. So before I continue, all this information you can also find in our website here at gams.com/academics, or also scanning this QR code here. And let me just mention again that we will share these slides with you after the webinar, so you will have all the links and the QR codes and everything. If we go to the next slide. Yes, so at the heart of our academic program is a free licensing scheme. So if you download GAMSPy, every distribution comes with a demo license where you can solve small models. But if you're a student, a professor, or a researcher, you can just head to our website and you'll find all the information on how to get a free GAMSPy license. It's a very simple process. All you have to do is sign up with your academic email address and in our portal, and you download a code and install it. It's very easy, and you will find all the information on our website. Also, if you are an academic, but you do not have an academic email address, you can just email us your student ID or your professor ID, and we'll do it for you. So our free licenses for academics, they are valid for 12 months. They are completely renewable. They come with no model size restrictions, which means that you can use it to solve all kinds of problems of any size. And as we were mentioning, this comes with access to all available open source solvers and even to multiple commercial solvers such as Cplex, Express Global, Copt, Mosaic, even Gurobi. And this really is a huge advantage because the solvers are state-of-the-art, they are the industry standards, and they can tackle complex problems very efficiently. So this means that you can do your research, your studies, or your teaching using professional grade tools completely for free. So if we go to the next slide. Yes, so beyond the free licenses, we have other resources that you can take advantage of. One is a community forum that is at forum.gams.com. And that is really a great place to connect with other GAMS and GAMSPy users from all over the world, and where you can ask questions. So if you're ever stuck with a problem, you don't know how a feature works, or you're simply getting an error and you don't know how to solve it, you can just post the question there, and the forum is super active, so you will probably get an answer from an expert very quickly. So please check it out, share your questions, and just take advantage of it to connect with other optimization experts. Then we also have a YouTube channel that has multiple tutorials and information. And we do have many new videos, particularly on GAMSPy coming up. So I would also recommend everyone to check it. Then I would also encourage everyone to read our blog post where we talk about anything that has to do with optimization, and to also check our case studies, because there you can find out more how optimization is used in real world problems and how the best and biggest players in multiple industries are using optimization and GAMS. And finally, we are also very excited to announce a new student competition specifically for the academic community in India. This competition will be similar to a hackathon where you have to solve a real-world optimization problem using GAMSPy in the course of maybe 1, 2, or 3 days. We haven't decided it yet, but you will be able to participate also in groups. There will be, of course, an interesting prize, and it will be basically a very good opportunity to test your optimization skills and also to show them to the rest of the optimization community. And we will send all the details of this competition via email in the next couple of days. So if we go to the next slide. Yes, so now we have some time for a Q&A question where we will address some of your questions. I saw that Mohammed he was answering a lot of the questions as we were speaking. Is there anything that's still open that we haven't answered yet? Someone is asking, for example, if we can do multi-objective optimization with GAMS. Do we have an answer for that?
Yeah, with GAMS, you can definitely do that. Actually, we have a page for that. Let me send a link. But for GAMSPy, it's not as straightforward at the moment. We are still working on that. Let's see. So this is the link. I send it as an answer, and I also send it to the chat.
Perfect. They're also asking if we can share the recorded version. Yes, we are recording the webinar and we will share it with everyone after via email. Okay, are there any other open questions? You can just post them in the chat and we will answer them. So they're asking a licensing question, someone who's a researcher and has completed their PhD using GAMS. And they would like to know after this, when they will not be affiliated anymore with the institute for a few months, if they can get a license. So right now, we only give free licenses if you're working within a degree granting academic institution. We are planning to have a program perhaps where you can take GAMS after your studies, but for now you need to be associated with an academic institution to have a free license. Any other question? Do we also send the Python code showed in the webinar? Yes, we will also send you the link so you can use it and test it yourself and play around with it.
Yeah, it's actually this code and a couple of more examples. There is a Google Colab file for all these examples that you can play around with and get to understand what GAMSPy can do. We can share the link after the presentation. That's fine.
Can we use GAMSPy in a Jupyter notebook?
Yes, we can. We can use GAMSPy in Jupyter Notebook. It's just as easy. You just have to have GAMSPy installed And after that, Jupyter Notebook or just simple Python script is it's irrelevant for GAMSPy.
Um, I also saw there, what is
Yeah.
the default solver for GAMSPy?
I already answered it, but I mean, this can change in the future. So we have a comment for that. GAMSPy lists solvers dash dash defaults. If you run that, you can see the default solver for each type of problem.
Mhm.
So at the moment, our default solver for LPs is Cplex. For NLPs, IP-opt. I mean, and for a MIP, it's Cplex as well. I am mentioning this because these are the most common problems that we receive usually. But if you want to see the whole list, you can just run GAMSPy list solvers and dash dash default.
Mhm. Then I'm seeing a couple more of licensing questions. If we have any specific question about whether you are eligible for a license, a free license or not, those questions I would recommend everyone to direct them to academic@gams.com, and then we can evaluate each particular case and give you a proper answer. What else? Is Gurobi free under academic license? Yes, so Gurobi offers free licenses for academics, and using the GAMS Gurobi link, you can use Gurobi for free if you have a free academic GAMSPy license.
Yeah, it's a fairly recent thing, and I think it's pretty cool because when I was an undergrad, for example, it was a huge issue. So I'm glad that we have this academic license now, so that students and professors, also assistants, researchers can use many solvers without any model size limitations.
Okay, then I'm seeing some more questions regarding, for example, when you have the GAMSPy academic license, how to set it up and confirming that you are not using the demo license anymore. So the process to install the academic license that you can find in our website in the documentation is very well documented and very, very simple, but you can also run a command. Mohammed, you can probably help me to check which license you are using.
I mean, to install a license, you can just run GAMSPy install license and your access code, or pet to your license file. And in order to verify which license you use, you can just say GAMSPy show license, and it would echo your license into the command line, basically.
Okay. Do you have any more questions here that we can answer?
Yes, do we need to mention explicitly? If we can't mention in pulp, it will call CBC as default solver. I am asking in that manner. Yeah, it's the same in GAMSPy. If you don't mention it at all, it will use the default solver for you. For example, if your problem is NLP, it's automatically going to use Cplex.
Okay, someone again asking if they are a student, but they don't have an academic email address, how do they do? Well, in that case, you have to email us to academic@gams.com, and you can send us either your student ID or a student certificate, and we will help you in that case. In how many days can I get my academic license if I requested it now? Well, if you do it through our academic portal, as you can find it on our website, that is immediate. You will get an access code and you just run the command GAMSPy install license and you get it immediately. And if you don't have the academic email address and you need to email us your student ID or certificate, that is usually done within 1 day. So it's pretty fast.
Yeah, I mean, maybe you can open academic.gams.com to show that we have the website for that. So if you have the academic email address, you don't have to ask anyone. You just go there and log in and get your license, and that's it. Yeah, this is the website. So you
There we have it.
basically enter your email address and
Mhm.
that's about it. And you can get your license.
It's a pretty straightforward and easy way of getting the license.
Yeah, exactly. That's academic.gams.com, and you can just put your email there, you sign up, and you get an access code. But that is, again, it's also very well documented in our website if you want to see exactly how the process works.
Mhm.
Oh, there's a question about Omelette. Actually, this integration is still on the way. We are working on it. It's not available yet, but it'll be available soon. So you will be able to use GAMSPy with Omelette in surrogate optimization pipelines.
Yes. Then again, we have more licensing questions. Someone is probably a professor who wants to teach the students. Again, if your students have an academic email address, they can get their own license to use it in their machines or in the university machines. And if they don't have the academic email, they just have to email us the student ID or certificate, and we will do it for them. So each of your students can get their own license for the computer or the university computer and use GAMSPy. Okay, do we have any more questions here? Okay, then I guess that's it for now. Thank you once again to everyone for joining us today for a GAMSPy webinar. We hope you found this session valuable and that you are excited to explore all the possibilities that GAMSPy has to offer. Any other questions or comments you might have left, please feel free to reach out to us at academic@gams.com, and also to subscribe to our newsletter to stay up to date with the latest news and information about upcoming events and also other webinars. Again, we will share these slides with you via email, so you can have all the links and the information, and you will also receive your participation certificate shortly via email. So again, thank you all for your time and for your interesting questions. This concludes our webinar. So thank you all. And
Thank you.
goodbye.
Thank you, everyone.
Thank
Bye-bye.
you.